Hello, PreCalc. This will be Wednesday, after class Wednesday video, and that will be the 26th. So we're still looking at our little puzzles, and I hope that you're having a fun time with them. I get the feeling, when the puzzle's all done and you get to put in that last piece, that's how you feel when you finish one of these little puzzles. So I hope you are enjoying it. Let's see if you can do these three. One minus cosine squared x over 1 minus secant squared x. And I don't have my Pythagorean IDs up here, but if you would open your comp book to them, it would be helpful. And I'm going to, instead putting those up, I'm going to put up the toolbox. So the toolbox has in it factoring, adding. That adding is algebraic adding with like denominators, and it has change to sine and cosine. And substitution. So substitution is going to be a big one where you look in your expression and see if there's anything like it in our trig IDs, which we're up to about 20 now. Make sure they're all in your comp book in a certain spot so you can easily refer to them. So we'll be checking that spot, so make sure you take some time to put those in there. You may come in and get something or put something down. Alright, so 1 minus cosine squared should ring a bell, and when you see that, you know that it's one of the Pythagorean IDs, and it happens to be sine squared. So that's one of the award winners, one of the award Pythagorean theorem, the Meritorious Service Award. So it's one of the forms of the Pythagorean ID, sine squared plus cosine squared equals 1. If you rearrange that, 1 minus cosine squared is sine squared. So you should be able to recognize that. So look into its eyes and see if you can recognize that the next time. That should be like a knee-jerk reaction. So next one, 1 minus secant squared is also a Pythagorean ID, almost, because what you're thinking, grabbing, let's see, whose thought cloud did I just grab? It looks like Dan's thought cloud. When I looked at his thought cloud, he was thinking, well, wait a minute, secant squared, 1 plus secant squared theta was tangent squared theta. So it was almost, or was it 1 minus? 1 minus, sorry. No, that's not it. Here's Dan's thought. He had it right. I just couldn't read his thoughts clearly. Secant squared theta minus 1 equals tangent squared. That's one of the award-winning Pythagorean IDs, rearranged. So this is almost like that if only the 1 and the secant squared were reversed. So if you look up your sleeve, or my sleeve, you will see the answer to that is we can take out a value. What's that value that we can take out? We can take out a -1, a negative sign, and that will change this positive to negative, and this negative to positive. So it will switch it around like that. And you can always check by distributing the negative back and seeing if you get back where you started from. So now this does match Dan's thought cloud, and so we can replace this with tangent squared. The negative sign comes along for the ride. It does not disappear, so it is still in the expression. So now I'm going to go to my toolbox, and I use substitution, but what else could I do now that I have sine squared over tangent squared? Well, one of the tools is changing everything to sine and cosine. So I'm going to do that with tangent. So here is where I'm going to work now. So let me grab somebody's thought cloud for that. Turns out I've got Kevin's thought cloud. So Kevin remembers, and I'm sure you do as well, that tangent, when I rewrite it as sine and cosine, is sine over cosine. But since tangent is squared, all I have to do to adjust is change each of these to squared. So sine squared over cosine squared is tangent squared. So I'm going to put that in the place of tangent squared. So I have an expression in the numerator, and now I have a fraction in the denominator. So whenever I'm dividing by a fraction, I like to make a fraction out of the numerator as well. So now I have a fraction divided by a fraction, and I flip that and multiply. And the sine squares cancel, and I get a cosine square. But I lost my negative sign, 2 hands up. It comes along in each of the steps. So the negative sign is still there. Minus cosine squared x is the answer. So here we have it right there, minus cosine squared x. All right. So going back, we had to use trig substitution from the Pythagorean IDs. We had to change tangent to sine and cosine, and then use some algebraic manipulation and found it was negative cosine squared x. All right, let's go ahead then and do 1 or 2 more. Since this is Wednesday night, right? All right, so you're all recovered from the trip, so let me get an erasure and do another one. All right, the second one, the command to simplify. We're looking at a little puzzle and we're trying to simplify it. And we are doing sine of theta, pi over 2 minus theta times cosecant theta, and I want to simplify that. Well, I always want to get pi over 2 minus theta out of my expression, so I can do that with a trig ID. So going to the trig ID, sine pi over 2 minus theta, would you go and find out which one is equivalent to this? So that will be easy to spot because there's only one section of IDs that look like this. Did you find it? Let me grab. I've got Bree's thought cloud. All right, here's what she's thinking. She's thinking, well, sine of the other angle is cosine of the angle. So there is a relationship that exists between sine and cosine, and that is it. So I can express this with just cosine of theta. And now we're almost done. What tool from the toolbox should we use here? We want to rewrite that with sine or cosine. So cosecant is 1 over sine. So now we stood sine on its head because that's the reciprocal of cosecant. So now multiplying, we get cosine over sine. And that is another trig ID, one of the award winners, and it is the cotangent. All right. So that's the correct answer for that one. I'm going to give you one to work on, see how far that you can get on it. And bring your efforts in your comp book tomorrow and we will check it out. Cosine beta, cotangent beta, plus sine of beta. All right, get used to working in different variables. They do not affect the way you do the problem. They just act like x or theta. Now remember, you had a fit when I introduced theta, so don't have a fit now that I introduced beta. It's a poem. All right, so cosine beta, cotangent beta, plus sine beta. I want you to simplify that, simplify it. I'll give you a clue on what tool to use. Go over here and change this to sine and cosine. So we're going to use that one. Then you will have you'll have to use this one. You're going to have to add these two together once you give it a like denominator. All right. So the two tools that you're going to need to pull out of the toolbox are change to sine and cosine and then add. All right. Get as far as you can on that one. I will then see you on Thursday, so you have a good rest of your Wednesday. So till then, we're done. Bye.